Ah.
Oh!
Okay.
Why did you do that?
So now,
Is it like free for download?
so what I did is then I said, okay, here's a pixel here, and here's a pixel here, you know, so we can get the locations of these pixels. And so I did that, and so if you look at the screen, as I move this around, look kind of down, clear down here in the lower right corner. See the numbers changing, the ones in the parentheses.
Yeah.
You know, like says 894, 375. So I got this darkest one there at 894, and I actually did 376. Oops.
So basically, each one of those squares is a magnified pixel?
That's right. And
Okay.
so I got the XY pixel location there, and then I went up to the middle here and got the pixel location. And you can see at 906.
And then you translated this into ARIAN Deck?
You'll know what not into ARIAN Deck. What I did is I wanted to get the number of pixels separation between the two. So
Okay.
I took the XY values here in pixel coordinates and XY here in pixel coordinates, subtracted the X ones, subtracted the Y ones, and I got 12 for one. So it was 12 this way. Oh, I should show. So it's 12 this way, 14 this way. Okay, so then I wanted to know, okay, what is it this way in pixels? And so I used Pythagoras for that, and I came up with 18.4 pixels. Okay? And so then I said, okay, let's look this up, and I found the Washington Double Star Catalog value number that corresponds to the V453 SEP. And so I went in, let's just go ahead and we'll go into the Washington Double Star Catalog.
So are there any other apps like this that are free? Because I'm not sure if I would exactly be allowed to buy one of these on my own.
Yeah, well, we can use this Maximum DL on the BART, but as Steve was saying, you can use the Salsa J or the Image J.
Okay.
Do the same
Yeah,
thing,
I'll
right,
check that
Steve? It'll give you pixel locations.
Yes, and I'm curious, Russ, because a lot of times for some of the HOU activities, we'll draw a line through even in a diagonal and get a pixel count separation, but I wonder if for our purposes, I mean, you're not going to get fractions of a pixel when that happens. I don't know.
Yeah, no, Steve, that's a really good point. The ideal way to do this, so this is just rough to see if this was a double star.
Okay.
What you really want to do is get the centroid of it to a fraction of a pixel.
And
Okay.
the
And
software
just
runs a little algorithm, something in.
The Salsa J thing is from the EUHOU website, right?
Yes.
Okay. And does that basically do the same thing as?
It does quite a few things. You can see some of the tutorials that are there, Umar.
Okay, cool. Yeah, I'll take a look at that.
Okay, so to kind of continue this thing, I'm going to go to the Washington Double Star Catalog, and this was, and you can write this down if you want. It was, the WS number was 22,52,7 plus 60,55. So we want to go to the 18 to 24 hour section. We'll click that. And now we want to scroll down to 22.
Can't you just do, since you're on a PC, Mr. Jennett, can't you just, left click and search find? Search for
You know, we could try that.
Okay.
And just for the records, it's actually Dr. Janae.
Oh, okay.
I don't see where usually there's a search page. At any rate, I'm going to scroll down here and And so 22, 52, 22,
In the
28.
WDS, are they, I'm looking at the left-hand side, that's where the RA and
Yeah.
definitions are.
Like it.
We're going to 22, 5, 27. We're almost there. 19, 28, 27. There we go. 22, 5, 27. And then it's 60, 55. Oh, there it is. So we located, I actually wrote this down. First observed in 1830, last observed in 2015.
Okay, so that's good. It has some sort of track record.
23 observations. The position angle started in 1830 as 142, and then by 2015 it was 137. Separation was 8.8 to begin with, and now it's 8.5.
So does that mean they're getting closer together?
Yes, that means they're getting closer together, exactly.
And is that normal for most star systems?
Oh, yeah, they'll either go closer or wider. And then here's the magnitude of one, 7.6, and magnitude of the other.
So why are the magnitudes different?
So it's a 3 magnitude difference. We actually wanted it less than that, but when we looked at that star, it sure looked like it was a big difference in magnitude. So now if it's 8.5 arc seconds separation, what we can do now is we can say, okay, we know the pixel scale, and the pixel scale I got from this image was 0.48. So let's divide 8.5 by 0.48, and we get what?
19.7.
No, we gotta get more than that. 8.5 divided by 17.7, right. And so this is saying from the Washington double star catalog and the pixel scale on our image, these two centers should be 17.7 seconds apart, or 17.7 pixels apart.
Right.
And if we go back to our image, so
We were 18.4.
that's right. And so that's pretty close.
Hmm.
And we can look, the other thing we can do is we can look at the position angle here. Because we think north is up and east is to the right, but let's check that. So from the Washington double star catalog, it said it was the last position angle was 137 degrees. So we go from the bright to the dim, and so if it was going around this way, that would be 90, that would be 180.
Right.
So,
And then right there in the middle would be about 135. So that seems about right.
yeah, so it's a good check that, and now what we haven't answered, so if we make this image smaller again, and I'm going to go over here and click manual and do high. Okay, so now, and we want to get this back. Okay, so now the other question we could do, we could find the center of this. I actually did a pinpoint plate solve. So I did a plate solve on the image, found the coordinates of the center, and so knowing the coordinates of the center in the pixel scale, we can do like we did on the other one, get the RA and work that out, get the deck and work that out, and then go from the center and go to the RA value and the deck value, and we hope, so if it comes close, then we know that's it. We've got 3 lines of evidence. We've got the separation is about right, the position angle about right, although that would probably mean east is to the left here.
Wouldn't we expect the angle and the separation to change more between observations, or do these stars have a very long period?
So going back to the Washington double star catalog, I don't know if we still have that. Let's see. No, we don't, but I can read the values. So the, it changed from separate in the position angle, which isn't very much. So we wouldn't expect it to change a lot.
So over time, eventually these two binaries would combine into like a black hole or something else?
They could, but we actually don't know that this is a binary star. It may be just two stars coincidentally lined up.
So then, yeah, that's what I was getting at. So the fact that the measurements haven't changed in that long of a time would seem to indicate that, right? Because if we're getting a very similar measurement to what was gotten in 2015 to what was gotten in 1832, then they don't look like they're orbiting each other. Because if they were orbiting each other, we'd see more motion. Do I have that right?
Yes, that's right. And that thing you would have suspected is if they were orbiting each other and it was binary, there'd been lots of interest. And since they're fairly bright and they were first observed in the 1830, it was a binary pair. There would probably been 100 or more observations, maybe several hundred observations.
Right.
In a binary. So.
Okay. So we're looking for stuff that. So usually, one way to.
And I'm going to be right back. Excuse me. I'll be right back.
One way to verify this, probably be to get what an orbit looks like from previous historical data, and then see.
So some of the stars did have that instead. They had orbits predicted, and so there are stars that are known to be binary. But I guess the question is, now we know that optical binaries, which it appears this one is, aren't really that interesting because they're not really orbiting each other.
Right.
And stars that are orbiting each other, we want to solve their orbit to get their masses. But if that's already been done, if the orbit is pretty much known, we're not really adding anything to that by making another observation unless we see something that says it's not really going in that orbit. Like what we want, if I have this.
Like if we have these two binary stars,
then
have
observe
a large
past, but they're not sure of its orbit.
Well,
Is that kind of the idea here? Yeah, okay, Rachel's nodding. Yes. So Russ, I was just saying, I think, so it seems like what we want is a star. So these stars look like they're optical binaries. And it doesn't seem like we'd be adding much to like the knowledge to say like, yeah, we think they're optical binaries too. But we also wouldn't be adding too much if we got a star whose orbit had been solved conclusively, right? Is there like a sweet spot where we want some observations but not quite enough to solve the orbit? And if so, how do we look for those kinds of stars in Stelladopy?
Yes,
well, I mean, there should be a field in Stelladopy that has like the number of observations. And here they also have like a date first and date last thing. And they do have like a discovery number. So what is the number of discoveries that we want like kind of range for?
Well, to answer the question, it's kind of if it hasn't moved in 100 years significantly, then it's probably no catalog. I think it has 2,200, and there's another catalog that has more. But you can sit there and